Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are talking about Chapter 4 review sheet in geometry. This is sent in by a student, and the student had two very specific types of questions. And so these are the exact questions that show up, just paraphrased a little bit so that I'm not writing sentences on sentences. Okay. So the very first type of question that the student had is how do you write an equation of a line that is parallel or perpendicular to another line passing through a specific point? So when we're looking for parallel lines, we know that we have to have the same slope, okay? So the reason why we're given the original line is that we want to find this slope. So we need 8. We need that information. Now, if you've ever been tutored by me before, most of the time I have students who tell me, oh, it's really hard for me to find the new y-intercept and this and that. One of my favorite ways to write an equation of a line is using point slope form. The reason why I like point slope form so much is because it's the most basic, and all you have to do is fill things in that you're given. So, excuse me. So, for example, I know that that's my slope, and I know that this is my point, x1 and y1. So, all I'm going to do is replace these three numbers in this equation and then solve for y to get my b. Now, you can absolutely use slope-intercept form. You're I don't know if there's going to be more math, less math. I don't know that I've done it, but I know that it's the easiest to replace these three particular things in this example, in this type of way to write an equation of a line. So you can go in and you can say, I have y minus -3 equals my slope of 8 times x minus regular 3. And then I go ahead and distribute and simplify. So this will be y plus 3 equals 8x minus 24. And then I subtract 3 from both sides, and I get y equals 8x minus 27. And this is my new y-intercept, the y-intercept of the new line. Now, one of the options is I could technically leave it here if the instructions didn't say, oh, it needs to be in slope-intercept form. Oh, it needs to be in this form or whatever form that it needs to be, right? So technically I could leave it like this and it'll be totally fine because I've just now written an equation of a line with information. I could even go so far as to say leave it in here, but maybe change this into a big plus. And that will also be fine. Or you could go all the way down here and simplify as much as humanly possible. And that's it. Those are 3 possible options. Now, if your tests are multiple choice, obviously what you're going to do is you're going to see which format they're in and then use that to really do a process of elimination so that you can understand which is the proper answer. Okay. So the second type of question was the same kind of thing, except it was a perpendicular line. Now, perpendicular lines have what's called negative reciprocals, reciprocal slopes. Meaning if I have, this is my original slope, right? So I'm going to go from -8/13. It's going to go from negative to positive. That's what this negative means. It's going to be positive. And reciprocal just means to flip, right? To go from numerator to denominator, from denominator to numerator. So it's going to be positive 13/8. Now I can already tell these numbers are really gross and they're going to give you a really gross answer. Again, if you have multiple choice as your option, definitely go ahead and see what options you're given so that you know which method to use in order to write the actual equation of the line. If it's not multiple choice and it doesn't really say like, oh, it has to be this particular type, it's totally fine if you leave it in this point slope form. So what I have here is y minus y1 equals my slope times x minus x1. And then I can go ahead and leave this. So I know that this is going to be my new slope, right? This whole business here. And I kind of don't even need the positive. That's fine. And this will be my x1, y1. So I'm going to go y minus 6 equals 13 over 8 times x minus 9 and call it good. Now, in this particular case, to be frank, if I were a geometry teacher and I would have students do that, because the slope is so gross and disgusting and nothing will simplify, I would say just leave it as is. I would say not a problem. There are some teachers who say, no, you absolutely have to distribute. So let's go ahead and let's distribute to see what's happening. So I'm going to have 13 over 8x minus 13 times 9 is 90, 117 over 8. Then I'm going to add 6 to both sides. But because I know I have a fraction, I know I absolutely need to have common denominators. So I'm going to put this over 8, or I guess I'm going to put it over 1 to figure out what it is as 8. So I'm going to end up doing, I'm going to do this side work here. Negative 117 over 8 plus 48 over 8. So that's just, we're going to subtract 0, 1, 17, 10, 17, so 9 and 6. So y equals 13 over 8x, it's an 8, minus 69 over 8. I, again, honestly would leave it as is. I would not turn this into any sort of mixed numbers. I would leave it improper. Regardless of where you are, sloped will always be left improper. It should not be changed into a mixed number. So I think it's only fair to say that both the slope and the y-intercept should be left as is, as improper fractions. Okay, so that's the first type of problem that the student had. The second type of problem, and because I'm such a fabulous artist, I drew this beautiful double triangle. The image was a little bit different, but the idea is still the same. The next three questions are the same. The questions were, what is the scale factor? And is this a reduction or an enlargement? So one of the things that you absolutely need to understand is when you're looking at this kind of progression, you want to notice that this PC business right here, that's the original piece, okay? And so once you notice that that's the original piece, you can then go ahead and say, hey, my original PC or C, I guess CP is going to be 12 units, whatever units they are, inches, feet, it doesn't matter. And then my new one, right, C to P prime, is going to be 39. Now, I know I'm increasing going from 12 to 39. I'm getting larger. So this is going to be an enlargement. Now, when I'm thinking of enlargement, I'm thinking double, triple, quadruple, quintuple, right? Like I'm thinking of multiplying by a whole number or a mixed number, right? So like 2.5 times is great. 10.5 times is great. So that means what's going to happen is I'm going to take this 39 and divide it by 12 to give my actual scale factor. Now, 39 divided by 12 is going to be a little bit gross in like decimal form, but what I can do is I know that 3 goes into both of these. So I would simplify by dividing both by 3 to end up with 13 over 4. And I can say that this is my scale factor because it is fully simplified. Or I can go in and say, you know what, 4 goes into 13 3 times with 1/4 left over. That is also an option. Again, if you're taking a multiple choice test, make sure that you're paying attention to the type of numbers that you have. Okay. And again, once you realize that this is an enlargement, it'll be pretty easy to tell which number we're dividing by what. The larger number goes on the top because it's an enlargement. Okay. In the next problem, however, what you will notice is that you actually have CP is this whole business here, right? And so what's happening is that essentially you're going from this whole 24, right? Because CP is 24, and then CP prime is only 9. So you're going from a bigger thing to a smaller thing. So you're taking like a half, a third, a fifth, a tenth, a 100th of the original size, right? So this is in fact a reduction. You're kind of making things smaller so they'll fit better on whatever it is that we're fitting things onto. I don't even know what this is. Um, and so in this case, because it's a reduction, we're going to go 9 over 24 to find our scale factor. I would not accept this if this were left like this because I know both of these are divisible by 3. And as a geometry student, regardless of the grade level that you're in, my expectation is that a geometry student would look at this and know exactly, oh, for sure, we are going ahead and simplifying this, you know? If you're like a sixth grader, I'd be maybe a little bit more lenient on a first test, but on a chapter 4 test, probably not so much. So I know this is going to be 3 over 8, and 3 over 8 would be my scale factor. Now, this image originally was a three-dimensional shape. I'm not quite sure how to draw this three-dimensionally. Maybe like I don't even know like that, but that kind of looks kind of funny to me, and so I decided against it. So just so you know, for the next problem, which is looks original picture looks kind of like a spider web. I just drew a straight line because that's all that's super important for me. And frankly, if I wanted to, I could erase all of this, and that would be the only important thing for me in order to help me realize what this entire problem is asking and what this entire problem actually needs in order for me to solve it. Okay. So again, we're looking for the scale factor and we're looking to see if it's a reduction or an enlargement. So one thing that I absolutely need to know is that this is my original piece. CP is 9 and CP prime, sorry, is 30. So I'm going from small to big, and that's going to be an enlargement. Honestly, like this picture, if you were to see it, it was a little bit too much, too exciting. And all it said was kind of like it had this like little piece, and then it had a bigger piece, and it was kind of like that, and it had like things going kind of like that. And then it had kind of like again the same business. So kind of like a spider web. And this was my C, and this was my P, and this was my P prime. And on the bottom, it said C prime is 30. And they gave you over here that this is 9. So you kind of had to visualize that it's going from the smaller piece to this larger piece. I'm going to erase all this because I think it's just a little bit ridiculous. And I think once you realize that you're looking just for a specific line, it's super easy to tell if something is an enlargement or a reduction. And because we're enlarging something, we want a number greater than 1. And so if I were to put 9 over 30, that's a small fraction, right? That's like 9 pieces of cake out of a whole 30 pieces of cake. Like that's not really a lot. That's like less than half, right? It's even less than a third. So it's like really a small portion. And I don't want that small portion. I want a larger. I want to enlarge my portion. So I'm going to go 30 over 9. Now I know again here that 30 over 9 is capable of being simplified by 3. And I wonder if the person who made this worksheet up just really enjoys simplifying by 3s, or maybe 3 is the person's favorite number. But it is what it is. So 10 divided by 3 is, 30 divided by 10 is 3, and 9 divided by 3 is 3 also. And so this would be my scale factor because it is fully simplified. Make sure that whenever you're trying to find your scale factor that you are looking for the most simplified version possible. Okay. I hope that this was super helpful, and I will see you in another video. Bye.